let us discuss about the law of conservation of momentum. Okay, so now what is this? So suppose you have these two marbles. Okay, this marble, it is moving on this floor with velocity u1. You can consider a marble or a ball or any body. Suppose it's moving on this floor with velocity u1, and there is another marble or another ball, let's say ball which has mass m2. It is following the first mass. Okay, it is following the first ball and it's moving with velocity u2, and they are moving in same straight line. Okay, so now if u2 is greater than u1, then what will happen? The second ball, it will collide with the first ball. Okay, now imagine what will happen at the time of collision. So the first ball will exert a force on the second ball, and the second ball, it will exert a force on first ball, right? And these two forces will be equal and opposite. Okay, these two forces will be equal and opposite. This is according to Newton's third law. After that, so now after that what happens? The first ball, it will be speed up, okay, and the second ball will be slowed down, right? First ball will speed up, and second ball, it will slow down. Yes, no, this thing is clear? All right, now let's start from this point, that F21, this is the force acting on the second ball or which has mass m2 due to the mass m1, and F12 is the force acting on mass m1 due to mass m2. Okay, so according to Newton's third law, we can say that F12, it is equal to minus of F21, and if the masses are not changing, then we can just say that force is equal to mass into acceleration. So force acting on first ball due to the second ball is equal to force acting on the first ball. It is mass of first ball multiplied by its acceleration. So m1 a1, and force acting on the second ball, it's equal to mass of the second ball multiplied by its acceleration, right? Then we can write the acceleration of first ball will be equal to v1 minus u1 divided by the time, right, delta t. Okay, and acceleration of second one, we can say it's v2 minus u2 divided by the time, okay, t or delta t, right? So acceleration of first one can be written as v1 minus u1 upon t1, and acceleration of second one is v2 minus u2 divided by t2. Now this t1 is equal to t2 because the force will act till the time the two bodies are in contact, and they are in contact for the same time, right? Okay, so if first body is in contact with second body, then second body must be in contact with first body. So time of contact is equal. So t1 is equal to t2. You can cancel it out, and then you can rearrange the terms. Okay, you can multiply out with m1 and m2. You can rearrange the terms, and then what do you get is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, right? So what is this thing? This is momentum of first body before collision, momentum of first ball. This is momentum of second ball before collision. This is momentum of first ball after collision. This is momentum of second ball after collision. So if you add up the moment of two balls before collision, it's equal to momenta of two balls after the collision. Okay, so total initial momentum is equal to total final momentum, right? Total initial momentum is equal to total final momentum. This is clear? Okay, and if collision happens in 3 dimensions, then we can make use of vectors. So m1 u1 bar plus m2 u2 bar will be equal to m1 v1 bar plus m2 v2 bar. Right? So See, how can we write? So in this case, see what's happening is, if you consider these two bodies, okay, as one system, okay, these two balls as one system, so then if there is no external force acting on the system, the total momentum of the system remains constant, it remains conserved, because there is no external force. If these two bodies are colliding and you call those two bodies are as one system, then these are the internal forces only. Okay, if you call these two bodies as one system, okay, if you call collection of bodies as one system, then these two are the forces within that system, so they are called as internal forces. So there is no external force, there is no external unbalanced force, and that's why the total momentum of the system remains constant. Right, this thing is clear? Yes, no? Okay, so this is the law of conservation of momentum. So how can I state that? It's very simple. The total momentum of an isolated system remains conserved in absence of an external unbalanced force. So this is the law of conservation of momentum, right? So this is the law. So this is very simple, and it has got many applications. Okay, so for an example, suppose you have this gun or pistol, and what you do is you fire a bullet from the gun. Then what is the initial momentum? Total initial momentum. Total initial momentum is 0. The gun is at rest, bullet is also at rest. Then when you fire a bullet, what happens? Gun gets a recoil. Okay, gun recoils backwards. So what will be its recoil velocity? You can find it out. So total initial momentum is equal to 0, because gun is at rest, the bullet is inside the gun, it is also at rest. Then what you do is you exert a force on the bullet in forward direction. So bullet also exerts a force on gun in backwards direction. So total initial momentum is 0. Total final momentum will be equal to what? Mass of gun multiplied by speed of gun or velocity of gun plus mass of bullet multiplied by velocity of bullet. And from this one, you can say that mass of bullet times or let's say mass of gun times velocity of gun is just equal to mass of bullet minus of mass of bullet into velocity of bullet, and you can find it out. You can find out the velocity of gun, right, given the velocity of bullet and masses of those two things. Okay, so this is one example. Another example is, we know that there are some radioactive substances. Okay, for an example, uranium is a radioactive substance, and now suppose it decays. So uranium decays into some other nucleus, okay, plus an alpha particle. Okay, it emits some particle. So this is the parent nucleus, it will have some initial momentum. So initial momentum of this parent nucleus is A, okay, Pa. Then it's equal to sum of the momenta of the daughter nucleus and whatever particle it throws out, right? So sum of the momentum of those two. If this one is at rest, then the momentum of the daughter nucleus plus momentum of this particle thrown out. If you add it up, the total momentum will be equal to 0. Okay, another example. Then you have a firecracker, right? A firecracker. It breaks into several pieces, but you can consider not one, 2 or 3 pieces. Then what will happen? The sum of momenta of those pieces is equal to 0, because initially the firecracker is at rest. So there are certain problems like this. Or suppose there is a rocket, okay, Diwali rocket, which is projected in air, and in air it breaks into several pieces in the air. Okay, let's say at the topmost position. Then what will happen? So what will be the total momentum? At topmost position, total momentum is mass of the rocket multiplied by horizontal velocity, right? And then that is total momentum. So that is total momentum before explosion, you can say. Then there will be total momentum after explosion, which is equal to total momentum before the explosion. Okay, all right. So this is the law of conservation of momentum. It comes from the Newton's third law. So after that, there is one particular thing which is applicable to Newton's laws of motion. Is the Newton's laws of motion are applicable in a certain frame. So now what is a frame? So we define frame of reference. Okay, we measure the distances, velocities, acceleration in reference to something, right? So suppose I am measuring it, then I am measuring it with respect to my position. Okay, so what is a frame of reference? Frame of reference just means there is an observer, okay, and he has access to a coordinate system, means he can measure the distances, and he has access to a clock. So observer who can measure the distances and time, that is frame of reference. This thing is clear. What is frame of reference? It's the observer who has access to a coordinate system, means he can measure the distances reliably, and he has a clock, so he can measure time also, right? So then there are two types of frames of references. One is the inertial frame, another one is non-inertial frame of reference. So what is inertial frame? So observer is either at rest, absolute rest, or he is moving with uniform velocity. Okay, observer is either at rest or moving with uniform velocity. So that is inertial frame of reference. Okay, then if observer is accelerating, then the frame of reference attached with that observer is non-inertial frame. Okay, so if observer is at rest or moving with uniform velocity, we say that he is in inertial frame of reference. Observer is accelerating, we say that he is in non-inertial frame of reference. Then Newton's laws, they are only applicable in the inertial frame of reference. If non-inertial observer tries to find out the force, etc., okay, he will calculate it wrongly. Okay, so Newton's laws are not valid in the non-inertial frame of reference. Okay, and this observer can find out the force that is acting on anything correctly, and this observer, non-inertial observer, cannot find out the forces correctly. Okay, this thing is clear? Yes, no? Right, good. So then just to give you an example, suppose this is me, I am standing over here, and this is somebody, okay, who is inside a car. So now first let's imagine that this car, it is at rest. Okay, so now the car is at rest and I am also at rest. Okay, I am standing over there. Then what will happen? So see, I see that car, and I see that, see, there will be total weight of the car and the driver, which is mg, it's acting downwards. There is a normal reaction which is acting upwards. Okay, so then I see the car is at rest and I reason that normal reaction and the weight, it is balanced, right? The two forces are balanced and that's why the car is at rest. There is no problem. Okay, then the car is moving with certain velocity. Okay, car is moving with certain velocity. So I can reason that since car is coming towards me with certain velocity, it's not accelerating. Suppose I have access to speed of the car. That means I can measure the speed of the car. So it's moving with certain velocity and velocity is constant. Then I can say again, I can see two forces. One is normal reaction, one is the gravitational force. Okay, and I can think that there might be a force exerted by engine of the car. Okay, but it cancels out with the frictional force, and that's why what's happening is the velocity of the car is constant because net force is equal to 0, right? So in those two cases, so suppose this driver doesn't know that the car is moving, it won't happen, but let's say, okay, so driver sees the world outside, okay, this person, and in these two cases, first he is at rest, then he sees B, okay, which is me, is at rest. Okay, so he sees that there is a normal reaction acting upwards, weight is acting downwards, two are balanced, and that's why he is at rest. Okay, then so this is one case. Second case, actually the car is moving, but suppose he doesn't know that the car is moving, right? Okay, just to give you an example, suppose you are sitting in a train and you don't have access to platform, you can't see the platform, etc. You can see the train which is beside you, and now one of the two trains begins to move. Even if the second train begins to move, you will feel that your train is moving. Okay, it's very difficult to find out if you are sitting in an AC cabin, right? Okay, so imagine the same thing happens with this driver in the car. Okay, so just relate these two things. So what's happening is this driver is watching this guy, okay, or suppose not the driver, there is some monkey sitting on the roof of this car and he doesn't know, obviously, right, whether the car is moving or whether this person is moving. But suppose the monkey knows Newton's laws. Okay, monkey can find out the force. So some monkey is sitting over here and he watches this person and he sees that, oh, person is moving in this direction. If car moves in this direction, the monkey will of course see that person is moving in this direction, and then he reasons there is a normal reaction acting upwards, there is gravitational force acting downwards, that is the weight, the two cancel out. Okay, no problem, the person can move with constant velocity, right? Then imagine the third case. Third case is car is accelerating. Now car is accelerating, suppose. Okay, so this person can correctly figure out, because he is at rest, he can figure out that there is acceleration, so there must be a force due to engine of the car, etc. So that force would be in this direction. What is the net force acting on the car? It is equal to mass of the car and this driver and the monkey. Okay, that's the total mass multiplied by acceleration, right? But now think about the monkey, poor monkey. Okay, he looks at this person and he sees that person is accelerating towards him, okay, towards the monkey, and then he sees there is a normal reaction acting upwards. Okay, there is a gravitational force acting downwards, that is the weight, and these two cancel out. Okay, and since the person is accelerating, there must be a force acting on this person in this direction. That force is equal to ma, mass of the person multiplied by the acceleration, right? This thing is clear. So okay, so for this monkey, monkey is in non-inertial frame of reference and he couldn't find the correct force. Okay, correct force acting on this person is 0, but monkey found that the force is equal to mass of this person times the acceleration. Okay, this thing is clear. Okay, and on everything he will find out the same force. See, the monkey is sitting over here and car accelerates in this direction. What will happen? So monkey will be pulled back like this. Okay, just like suppose you are standing in a bus and bus suddenly takes a start, okay, with some acceleration a, then what happens? You get a backward momentum, a backward jerk like this, right? Same thing will happen with the monkey. If car takes sudden start with some acceleration, the monkey will be pulled back. Okay, actually what happens is monkey, see, according to Newton's first law, everything tries to be in its state of rest or of uniform motion. This property of bodies is called as inertia. So monkey tries to be at rest. Okay, not tries, it is the inherent tendency of bodies to be at rest if bodies are at rest, and to be in uniform motion if they are in uniform motion. So monkey tries to be in uniform motion, but what's happening? The car is moving in this direction. Okay, and because you can say monkey is sitting on the car, so there is contact between the monkey and the car, right? So there would be some friction, because of which the car won't let the monkey slide down. Okay, but there is some movability in the body, okay, or you can say mobility inside the body, internal flexibility. So legs of monkey, they will move along with the car, but the monkey, his upper part of the monkey's body, it remains at rest there, and that's why one part remains at rest, another part is moving in forward direction. So what will he feel? He will feel a force in backward direction, right? So he will force a force in other direction on everything, not only on this person, on himself also. So this force is known as a pseudo force. Okay, this force is known as a pseudo force. So this thing is clear. Okay, so pseudo force, because it's not a real force, it is not the real force, it is the force calculated, it is force calculated by a non-inertial observer, okay, accelerating with acceleration a. Okay, so this force is equal to F is equal to mass multiplied by acceleration, but it acts in the opposite direction. So see, that monkey is accelerating in this direction, but he calculates the force on this person in the opposite direction. How much force does he calculate? Mass of this person multiplied by the acceleration, okay, but in opposite direction. So this is not a real force, it's calculated by an observer who is in non-inertial frame of reference. So this is called as a pseudo force. Okay, this is a pseudo force. Right, this is a pseudo force. So now if you want to solve any problem thinking in terms of non-inertial frame of reference, then you need to include this force. Okay, you need to include this force which is called as pseudo force. Okay, so let's put suffix p here, p for pseudo, right? And also this force is felt by that person. Okay, there is no real origin. there is no real origin, to the pseudo force. Right, this thing is clear, everyone? Okay, good. All right, so then now we discussed law of conservation of momentum. Let's discuss some problems based upon that, and pseudo force, the concept of pseudo force, will make use of it sometimes. Okay, all right, so let's see this one. A shell in flight explodes into 4 unequal parts. Which of the following is conserved? Tell me. Potential energy, momentum. Yeah, momentum is the answer. Right, very good, very simple. Let's see next one. A man fires a bullet of mass 200 gram at speed of 5 meters per second. The gun is of 1 kg mass. By what velocity the gun rebounds backwards? So again, you can say, using the law of conservation of momentum, that mass of gun times velocity of gun plus mass of bullet times velocity of bullet is equal to 0. Okay, because total momentum before firing is equal to total momentum after firing, and total momentum before firing was 0, right? And that's why the total momentum after firing is also equal to 0. Okay, very, very simple. And we want to find out the velocity of gun. So let's take this thing on other side. So you get mg times mass of gun times velocity of gun is equal to minus of mass of bullet times velocity of bullet, and therefore velocity of gun is just equal to minus of mass of bullet times velocity of bullet divided by mass of the gun. Okay, yeah, it's option A. Let's check. So you can directly do this thing, okay, in this kind of problems. So mass of bullet is 200 grams. So that is 200 multiplied by 10 raised to minus 3 kgs or 0.2 kg. Okay, multiplied by velocity is 5 divided by mass of the gun is 1 kg. So 200 times 5 is 1000, 1000 times 10 raised to minus 3. Yeah, good. So that is minus 1 meters per second. So this negative sign just tells that it is moving in opposite direction as that of the bullet. Okay, but the magnitude is 1 meters per second. Okay, so this is very, very simple question, right? Yeah, it's simple. Let's see another question. A mass of 1 kg is thrown up with a velocity of 100 meters per second. After 5 seconds, it explodes into 2 parts. One part of mass 400 gram comes down with a velocity of 25 meters per second. The velocity of other part is, tell me. Mass of 1 kg is thrown up with velocity of 100 meters per second. After 5 seconds, it explodes into 2 parts. Okay, one part of mass 400 gram comes down with a velocity of 25 meters per second, and the velocity of other part is. So again, this problem is also simple. A mass of 1 kg is thrown up. Okay, so let's say this ball is thrown up, it moves till some height. Okay, and at this height it breaks into 2 pieces like this, and this piece comes down, okay, with some velocity. One piece comes down, the other piece will keep on moving up, but its velocity will change, right? Okay, so let's say this is m1, this another one is m2. Okay, so what is we need to calculate what is the momentum of this ball when it moves. Okay, after 5 seconds, what is the momentum of this ball? We need to calculate, right? So let's do that. Okay, v is equal to u plus at, that's correct. So here a will be equal to minus g, right, and therefore we'll have u minus gt, and that is equal to, what is u? U is 100 meters per second, minus you have g equals to what? 10 times 5, time is 5, right? So 100 minus 50, that's 50 meters per second. Okay, so we got the initial velocity, and then we have initial momentum m times v, it will be equal to m1 v1 plus m2 v2, right? First mass is 400 grams, so that is 0.4 kgs, okay, and then okay, mass times velocity, what is the mass? 1 times 50, it's equal to m1 v1, so that's 0.4 multiplied by, now it's moving down, right, it is moving down, okay, with velocity of 25 meters per second. So velocity is 25 meters per second, but it is moving down, so that's why we need to take negative sign, minus 25 meters per second, right? Plus we'll have the mass of another part, because mass of first part is 0.4, mass of second part would be 0.6, so it's 0.6 multiplied by v2, we need to find out v2, right? So this thing will be 0.4 times 25, how much is this? I guess it is 10, because 25 times 4 is 100, so you have 0.4, so it would be 10 minus 10, move it on other side, so you will get 50 plus 10, that is 60, so 0.6 v2 is equal to 60, and therefore v2 is equal to what? 60 divided by 0.6, so that is 100, right, 100 meters per second. Yes, no? Check my calculation, whether it's correct or not. Oh, again, yeah, correct, no? Okay, good. Alright, so let's move on to the next problem. A body of mass 5 kg explode. A body of mass 5 kg explodes at rest into 3 fragments with masses in the ratio of 1:1:3. Okay, 3 fragments. The fragments with equal masses fly in mutually perpendicular directions with speeds of 21 meters per second. The velocity of heaviest fragment in meters per second will be. So tell me. Okay, this one I will explain. So see, a body is there and it explodes into 3 fragments. So suppose one goes like this, okay. So the fragments with equal masses fly in mutually perpendicular directions. So suppose one flies like this, another one flies like this, one flies like this, they have equal masses, okay. So let's say mass of this one is m, mass of this one is m, and their velocities are they fly with equal velocity. So let's say v times, this is moving in y direction, so I will call j cap, this is v times I cap, and the other one, because total momentum must be equal to 0, so other one must fly with this in this direction, right? Okay, so let's say its velocity is v dash, okay, v dash bar. So what would be its mass? Mass of this one is m, mass of this one is m, mass of this one must be 3m, right? And then before explosion the total momentum was 0 because this one was at rest, okay, and it explodes, right, into these 3. So total momentum after explosion must also be equal to 0. So just add the momentum of all 3. So total momentum after explosion is 0, Okay, momentum after explosion is equal to 0, and therefore you have m times v into I cap plus m times v into j cap plus 3m times v dash bar, it's equal to 0. Then you can cancel out m from everywhere. Okay, and then you can move this thing on other side. Okay, yeah, then you can move this thing on other side, so you will get v dash bar is equal to minus of v I cap plus v j cap, and that is, what's this thing? It's option A. Let's check. So what is v? Okay, that 3 is also there, so that 3 also you will move on the other side, it will go in the denominator, right? So v is 21, so it is equal to 21 I cap plus 21 j cap divided by 3. Okay, so that is 7 I cap plus 7 j cap. So minus 7 I cap plus 7 j cap. But they are not asking about the velocity. We should be able to calculate the velocity also, right? So velocity will be given by this formula. What is the speed? Speed will be just magnitude of this thing. Okay, so therefore v dash is equal to, magnitude is square root of vx square plus vy square, 7 square plus 7 square. Okay, so that is 2 times of 7 square, and if you take root of that, it will be 7 root 2. So that's correct. Okay, it's option A. So this is clear? Yes, no? Okay, and this one is repeated, right? This one is repeated. Maybe the masses are changed, maybe the proportion is changed and velocity changed, but this one is repeated. Okay, let's see next one. A 1 kg stationary bomb is exploded in 3 parts having mass 1:1:3. Okay, the ratio of mass is 1:1:3 respectively. The parts having same mass move in perpendicular direction. So again, parts having same mass move in perpendicular direction with velocity of 30 meters per second. Then the velocity of bigger part will be. Okay, so this is simple. Shall we write directly? So if v is equal to 30 meters per second and ratio of masses is what? 1:1:3. Okay, then what will be the velocity of, what will be v dash bar? You can say it's minus of, it's option A. Again, let's check. So it is v times I cap plus v times j cap, okay, divided by this fraction, right, divided by 3. So that's equal to minus of, what is v? It's 30 I cap plus 30 j cap divided by 3. So right, it will be minus 10 I cap plus 10 j cap. Okay, so 10 root 2 would be the answer, right? So again, its magnitude is square root of 10 square plus 10 square. Okay, so 10 square plus 10 square, that is 10 root 2. So again, simple question, right? This is exactly same as that of the previous one. Okay, let's see next one. So an object flying in air with velocity this much suddenly breaks in 2 pieces whose masses are in ratio 1:5. The smaller mass flies off with a velocity of this one. The velocity of the larger piece will be, tell me. Okay, so let's suppose the smaller mass has mass m then the other one will have the mass 5m and initial mass is suppose m, you can say m1. So m1 is equal to m plus 5m means 6m, right? So let's say smaller one has mass m, the bigger one will have mass 5m, and because it's the one piece or one object which is breaking into these two pieces, its mass would be equal to 6m. Okay, so then you can say m1 multiplied by initial velocity, that's 20I plus 25j minus 12k must be equal to m1 v1 bar, or let's call this one as capital M, this one we'll call it as m1, this one as m2, just to explain. Okay, you don't need to do all these things. Okay, so first one, the initial mass has velocity v, its mass times velocity means momentum will be equal to m1 v1 bar plus m2 v2 bar, right? It's breaking into two masses m1 m2. Then we can substitute the values of m, okay, then m1 m2. So you can directly start with the second step, that is 6m multiplied by what's the velocity, this thing, okay, 20I cap plus 25j cap minus 12k cap, it's equal to what is m1, it's m, and that one has velocity of 100I cap plus 35j cap plus 8k cap, and the other one has mass 5m, its velocity we want to find out, velocity is v2. So then this m will get cancelled out, m gets cancelled out. Okay, and then we can move this thing on other side. So first of all multiply with this thing, so you have 120I cap plus 6 times 25 is 150j cap minus 72k cap is equal to 5v2 bar. Okay, and this thing, so this thing I will take on other side. So just subtract this. So 120 minus 100 is 20, and this thing is okay. So let's do it on next page. Okay, option A. Alright, let's check. So 120 minus 100 is 20I cap plus 150 minus 35 is 115 j cap minus 72 minus 8 is minus 80 k cap, that's equal to 5v2, and therefore v2 is equal to, just divide that by 5, so 4I cap plus 23 j cap minus 80 k cap, so 80 divided by 5 is 16 k cap, right? So this is the answer, 4I cap plus 23 j cap minus 16 k cap, right? It's option A. Okay, so this is just calculation. This one is clear? Yes, no? Okay, good. Let's see next one. An explosion breaks a rock into three parts in a horizontal plane. Okay, so they are moving in horizontal plane only. Two of them go off at right angles. See, I told you it is repeated many times. Okay, right angles to each other. The first part of mass 1 kg moves with the speed of 12 meters per second, and the second part of mass 2 kg moves with 8 meters per second speed. If the third part flies off with the speed of 4 meters per second, then its mass is, okay, no problem. So you have, let's say this is first one, this is second one, this is third one, okay, or this is first one, m1 v1 bar is something, okay, So it's moving in x direction. So let's say Vx into I cap, or let's say V1 is the speed into I cap, and for this one it will be m2 V2, m2 is mass, V2 is the speed, so V2 j cap, and for this one the velocity is V3 bar, let's say mass is m3. Okay, so then you can say that m1 V1 into I cap plus m2 V2 times j cap is equal to m3 V3. Okay, m3 V3 bar, right? So then what is the mass of first one? 1 kg, speed is 12, so 1 times 12 into I cap plus mass of second one is 2 kg, the speed is 8, so 2 times 8 into j cap, it's equal to, now third one flies off with 4 meters per second, this is given, speed is given, so we know that V3's magnitude is equal to 4. Okay, so you have m3 multiplied by V3 bar, so V3's magnitude is equal to 4, that you know. Alright, so then what will be this thing? This is 12 I cap plus 16 j cap, find out its magnitude, so magnitude of that will be equal to magnitude of m3 V3. Okay, so magnitude of this thing, therefore magnitude of V3 is equal to, you can say, square root of 12 square plus 16 square divided by m3, right? This is the magnitude of V3. You can say magnitude of m3 V3 bar is equal to square root of 12 square plus 16 square. Okay, and then what is 12 square? 144, right? What is 16 square? 256. So if you add it up, you get 400. Square root of that is 20. So you got V3 equals to 20 by m3, but V3 is given, so m3 is equal to 20 divided by V3. V3 is what? 4. So 20 by 4 means 5 meters per second. So this is the answer. Okay, this thing is clear? Yes, no? Okay, so this is very similar problem, nothing different. So, oh, m3 is equal to 5 kg. I wrote 5 meters per second, right? m3 is equal to 5 kgs. Okay, so these are the types of questions that are asked on momentum, conservation of momentum. So now let's talk about the next topic, that is friction. Okay, of course we know what is the friction, right? So for an example, suppose once again this is me and I want to move this block. This is heavy block, okay, like the cupboard which is behind me. Okay, so suppose this is heavy cupboard that I want to move. What I do is I exert some force. Okay, so initially I exert a force of, let's say, 10 newtons, and nothing happens to the cupboard, it doesn't move at all. I increase the force, okay, 20 newton, nothing happens to it. 50 newton, okay, nothing happens, right? 100 newton, nothing happens. 101 newton, it slides a little bit. So what does it mean? It means that when I exerted a force of 20 newton and it didn't move, it means that there must be some opposing force, okay, of equal magnitude, because I am exerting an unbalanced force. I want to unbalance it, right? It is, see, there are two forces, normal reaction and the force due to gravity. because of which it is balanced. I want to slide it, so I need to exert an external force, okay, but it doesn't move means this force is balanced by something else. So that is the frictional force. There is a force between this this body. It can be anything. So in this example it is a cupboard, but it can be anything. So this block, let's say, and the floor. So you are exerting a force in this direction, but that another force, which we call it as a frictional force, it opposes the sliding motion between the two bodies. Okay, friction opposes the relative motion between two objects, two bodies. Okay, so it will act in opposite direction. But when I exerted a force of 20 Newton, nothing happened, means friction was also 20 Newton. When I exerted a force of 50 Newton, nothing happened, means friction was also 50 Newton. When I exerted force of 100 Newton, still it didn't move, means friction was also 100 Newton. But when I exerted a force of 101 Newton, it moved slightly, means friction could go up to 100 Newton, but that was its limit. It couldn't exceed above that. Okay, so what is the friction? Friction is a force which opposes relative motion between two objects, and it is a self-adjusting force. Okay, so it adjusts itself according to the externally applied force, but there is a limit up to which it can grow. Okay, so there is a maximum limit to the frictional force. So friction is a self-adjusting force, and the maximum value of the friction is known as its limiting value, right? The maximum value up to which the friction can go, it is its limiting value. The friction can increase, right? The maximum value up to which the friction can increase is its limiting value. This thing is clear? Yes, no? Okay, good. Then now suppose you are exerting this force. Suppose I am exerting a force on that cupboard, and cupboard begins to move. But now if I remove the force, the cupboard will stop immediately, right? So to keep it moving, I need to keep on exerting some force to counter the friction. But now in comparison with the starting force that I need to exert, force required now would be lesser. Okay, force required now would be lesser. So the frictional force before one object slides over the another object, it is known as static friction. And once it begins to slide, now you need to apply lesser force, okay, to keep it moving with uniform velocity. So how much force do you need to apply? So the value of friction then, and it is known as the kinetic friction. Okay, so friction between two bodies when one is sliding over the another, it is known as kinetic friction. So the first one, when body is not yet sliding over the other body, it is known as static friction. Once it begins to slide, the friction between them is known as what? The kinetic friction. This is clear? Yes, no? And static friction is greater than kinetic friction. Okay, good. All right. Now let's come to the cause of friction. What is the cause of friction? So see, when you see this cupboard, okay, if it is made by a very good artist, let's say, okay, so it will look very smooth. Okay, the edges will be very smooth, surfaces will be very smooth, but this is what we can see with our naked eyes. If you look at the cupboard through the microscope, it will look something like this. Okay, if you look at the floor through the microscope, it will also look something like this. So the surface will not be very smooth. There will be minute hills and dales, minute irregularities in both surfaces, not both surfaces, all surfaces. So now when you keep one body over the another body, these hills and dales or irregularities of the two bodies, they interlock. they get interlocked with each other. Okay, and when you want to move this body over the another body, now what do you need to do? So see, there is this interlocking. Okay, so you need to slide this body over the another body, means you will need to lift it up, or you will need to destroy this much part of this body. Getting this? So for that you will need some force. Okay, so when you want to move this, let's say you want to move this one in this direction, what will happen? So this part will oppose it. Okay, right? So when you want to move it like this, so this part, it will break down. Okay, this part will break down, this little portion, it will be broken down. That's why you see, when you slide, let's say a cupboard on a floor, there are scratches on the floor. Okay, so where are those scratches coming from? These irregularities, they are you can say they are broken, and that's why you can see them as scratches. So this is one reason. Okay, so now see, this is quite intuitive. Okay, this is very easy to believe. Then suppose, for an example, you take two glass sheets, they're very smooth, and you keep them on top of each other like this. These are two glass sheets. Okay, so now what do you think? So here there was a friction because of what? Irregularities. Okay, the two surfaces were rough. Now the two surfaces are not at all rough, they are perfectly smooth. Now what will happen to the friction? Will it increase? Will it decrease? What do you think?
Decrease.
Okay, so if you make the surfaces smooth, the friction should decrease, right? And it will decrease to some extent. But now if you make two surfaces very smooth, perfectly smooth, then what will happen? There are no irregularities at all. Then see, this is one surface, this is another surface, and there are molecules in this surface, there are molecules in this surface. Okay, and now see, there is an intermolecular force. Now these two surfaces will be in contact with each other. Okay, what I can say is, if you consider molecules at the edges, so this molecule and this molecule, see, they are experiencing force due to other molecules. Okay, these molecules are experiencing force due to the other molecules which are in their surrounding. Now this molecule will experience force due to this molecule, and also molecules within this surface, because now there is no difference or no distance between these two surfaces. This molecule doesn't know whether this is the molecule of the same surface or the other surface. So there will be same force, right? Okay, there will be the same force. And now if you want to slide these molecules, so it is experiencing force due to this one, whatever comes in the range of molecular attraction, it will experience force due to all those molecules, and not just this one, all the molecules on the surface, because now they are very close. They will experience forces due to the molecules from the other surface, and this is called as cold weld. Okay, so a bonding will be formed between molecules of this surface and molecules of this surface. And now if you want to slide it, it will be very hard if the two surfaces are perfectly smooth, because molecules will be very close and molecules won't know whether they are molecules of this one or this one, right? So this is another reason. So in this case the friction will increase a lot. Okay, so you can try sliding one glass surface or the another one. Friction is huge. Okay, this is another reason. So now the interlocking is first reason, and here see, there are these molecules of this surface, these are molecules of another surface. and where the two surfaces are in contact like this, what happens is these molecules, they experience an attractive force due to these molecules. So temporary bonds are formed. Okay, temporary bonds are formed, and now if you want to slide one surface over the another surface, that means you need to separate these molecules from these molecules. Okay, and you need to break those temporary bonds. So those temporary bonds are called as cold weld. Okay, or cold welding. So you need to break those temporary bonds, right? And therefore to break them you will need a force. So that frictional force comes from these temporary bonds. Okay, so of course there are two reasons. So one is macroscopic reason, the irregularities. Actually it is also microscopic, but another reason is at the molecular level. So this thing is clear? Yes, no, everyone? All right, so these are the two reasons of friction. Okay, good. So then now the normal reaction and the friction are the two contact forces. Okay, the normal reaction and the friction are the two contact forces. So whenever there is a contact between two bodies, and if you want to slide one body over the another body, there will be two forces. Okay, two contact forces between this body and this body. One is the normal reaction, another one is the friction. Okay, so now what's the reason between, what's the relation between them? So we'll see that. So suppose R is the net contact force, total contact force or resultant contact force, okay, due to the contact between these two surfaces, and now this R makes an angle with the normal reaction. So this angle is known as the angle of friction. Okay, so angle made by the total contact force with the normal reaction is known as angle of friction, right? So they can ask you sometimes, what is the angle of friction? It is the angle made by total contact force with the normal reaction, that is angle of friction. So there are two angles here that we are going to study. The another one is called as angle of repose. Okay, and students, they often get confused between angle of friction and angle of repose. Okay, so they will come out to be equal, but they are not same. They are not same. Okay, I mean they will come out to be equal in value, but their definitions are different. What is angle of friction? It's the angle made by total contact force with the normal reaction. Okay, so now this total contact force is, suppose R bar, resultant contact force. You can resolve it in two components. So what will be N? N is equal to, you can say, R cos theta, and we are calling it theta F, F for angle of friction, right? F for friction. So N is R cos theta F, and what would be this frictional force? It is R sin theta F. Okay, so Fs max is the maximum value of the static frictional force. It is R sin theta F. So then you divide this one with this one. What do you get? RR will get cancelled out. Fs max divided by N is equal to tan of theta F. And what is Fs max then? What is Fs max? It's the maximum value of static frictional force. Okay, so maximum value of static frictional force will be, it is equal to tan of this angle, tan of the angle of friction times the normal reaction. Okay, so we need to remember this formula. Fs max is equal to what? Mu s multiplied by the normal reaction. This thing is clear? Okay, everyone? Alright, good. So Fs max is equal to mu s multiplied by normal reaction. We need to remember this thing. And then there are certain laws of friction, laws of static friction, laws of kinetic friction also. So let's see them. So first one is limiting value of static friction, which is Fs maximum value, Fs max, okay, it's directly proportional to the normal reaction. We just saw that Fs max is equal to mu s multiplied by normal reaction, where mu s is called as the coefficient of static friction. Okay, so Fs max is proportional to the normal reaction. Now if this block is resting on a horizontal floor, normal reaction is just equal to mg. But if the floor is not horizontal, if it is tilted, it is inclined at some angle, then it will not be same. Okay, normal reaction is not always equal to mg. Okay, we'll see that. All right, so limiting value of static frictional force is proportional to the normal reaction. Limiting value of static friction does not depend on the actual area of contact between two bodies. So this is little bit counterintuitive, you can say, but okay, this is not like what we expect. We would expect that if more area of contact is there, then friction would be more. But the friction is, it does not depend on the area of contact, actual area of contact. So that means, see, if I keep, so let's take these two examples. Okay, so in first case you have two bricks, suppose, or two blocks, or one block only, and in first case you keep it like this on this surface. Okay, and then you want to slide it, so the maximum frictional force would be equal to what? Mu s multiplied by normal reaction, right? And normal reaction is just equal to its weight, because normal reaction and weight, they will cancel out. This is the horizontal surface. Now you keep it like this, so still what will be static frictional force? It is mu s multiplied by normal reaction, and normal reaction in this case is also equal to what? It is equal to weight. Okay, so friction is equal, maximum value of friction is equal in both cases. Okay, so in first case area of contact is more, in the second case area of contact is less, but the frictional force is equal in both cases. This thing is clear? Yes, no? Right, good. And then now this is like, this is a common sense. It will depend, it will of course depend on the nature of two surfaces in contact, whether the two surfaces are, whether it's a metal or it's some wood. Okay, some metal or wood, right? Okay, so for different bodies, different kinds of bodies, the friction would be different, right? So this is the third law. So it depends on the nature of the surfaces between contact. So the nature of surfaces and type of surfaces means, nature means whether it is rough, it is smooth. Then if second thing, if it is iron, it is aluminum, or it is some wood, okay, that will change mu s. Okay, that will decide mu s, right? So this is third law. So these are three laws, very simple laws. Okay, and then let's talk about angle of repose. Now what is angle of repose? So see, suppose you have this block resting on this inclined plank, or suppose, see, there is an experiment like this. Suppose you take a body like this, this is an inclined plank, okay, and you take this body, you keep it over here. Okay, now suppose initially it is horizontal, and you can change the incline like this, you can change the incline. Okay, so what you did is, there is wooden plank, and you keep some body on top of that. Okay, and then you change the inclination. Initially it is horizontal, you change the inclination, you increase the inclination, increase. Oh, there is a problem here. Spain is magnetic. Sorry. I'm sorry, I forgot that. Okay, so let's try with different body. So suppose you take this plank and you keep some body on top of that. So I'm keeping my phone, and then you slide it like this. You increase this angle, you increase it at some angle. What happens? So you can see that it is sliding, right? So that angle is known as angle of repose. Okay, so this thing is clear. So it is the angle at which what happens, one body begins to slide over the body begins to slide over the plane, over the inclined plane. So that angle of inclination of the plane is known as angle of repose. Okay, so this is the difference between the angle of friction and angle of repose. This thing is clear, everyone? Yes, no? Okay, good. So then now it will turn out to be equal to angle of friction. So see, when this body slides, when this body just begins to slide, okay, so we need to find out what is the frictional force and what would be force in this direction. So now understand this diagram. So this is a body kept on this inclined plane. So this is the angle of inclination of the plane. So now what would be the two forces? One is the normal reaction. So normal means perpendicular, that is, it is always perpendicular to the plane of this surface, right? It's always perpendicular to the plane, right? Plane of this surface, we can say. This thing is clear? Yes, no? Normal reaction is always perpendicular to the surface. Okay, that's why it is called as a normal reaction. And friction is always along the surface. So if block slides in this direction, okay, down the plane, then friction would be acting up the plane, right? So then you have the gravity, okay, or weight of the block, it is always acting downwards. So these three forces are acting there. Okay, one is the normal reaction, which is always perpendicular to plane. One is gravity, which is downwards, and one force is friction, which is avoiding the sliding motion of this one. Okay, so when you keep on increasing this angle, what happens? The frictional force will also increase. Okay, and at some angle it will become maximum, but then it can't increase beyond that. So after that, what will happen? The block will begin to slide. Okay, so now what we'll do is, these two forces are already, one is the normal reaction, it is perpendicular to the motion. One is frictional force, it is parallel to the motion. There is gravity or the weight, which is not perpendicular, not parallel. What we need to do is, we need to take its components. Okay, we need to resolve it, parallel to motion and perpendicular to motion. Okay, so if you draw this line, if this angle is theta, see this angle would be 90 minus theta, and again this thing is 90 degrees. So that's why this angle is also equal to theta. Can you see that? This angle is theta. Okay, this angle is theta. So this angle is 90 minus theta. So therefore this angle is 90 degrees and this is 90 minus theta. So this angle is also equal to theta. And therefore now you resolve mg in two components. So component through the angle is cos component. So this one is mg cos theta and this one is mg sin theta. Right? This one is mg cos theta and this one is mg sin theta. So now for equilibrium of this body, so now let's say that still body is not moving, body is about to slide, it is just about to slide. So then this force and this force would be balanced, right? So for equilibrium along the plane, equilibrium means what? The forces are balanced, okay, forces are balanced. So for equilibrium along the plane, what will happen? This force and this force must be balanced. So Fs max is equal to what? Mg sin theta. And for equilibrium perpendiculars to plane, you have n is equal to mg cos theta. So n, normal reaction, must be balanced by mg cos theta. So you write that. So this is your equation 1, this is equation 2. Divide 1 by 2. So mg will get cancelled. You have Fs max upon n equals to tan theta. And from that, Fs max upon n is equal to tan theta. And you know that Fs max upon n is equal to mu s. So from this you get mu s is equal to tan theta, right? And this angle we are calling it as theta r. This is angle of repose, okay? And from here we get that angle of repose is just equal to the angle of friction. Okay, so that's what I said, they come out to be equal, but their definitions are different. Is this thing clear? Everyone, yes, no? Right? Okay, good. So remember this thing. Then there are laws of friction for kinetic friction, okay, and they are exactly same as that of static friction. So the limiting value of kinetic friction is directly proportional to normal reaction. Now here the limiting value of kinetic friction and the kinetic friction itself, they are equal, okay. It changes in only one case. So I can just say it is the value of kinetic friction, remember this, or it's coming actually. Limiting value of kinetic friction does not depend on total actual area of contact between two bodies, just like static friction. Limiting value of kinetic friction depends on the nature of two surfaces in contact, okay. The same thing, kinetic, whatever is applicable to static is applicable to kinetic friction also. And the limiting value of kinetic friction is independent of sliding velocity if the velocity is less than a particular value called as critical velocity. So okay, so now critical velocity is calculated for different bodies and it would be different. But then if the sliding, if one body is sliding or the another body with a velocity which is greater than critical velocity, then you can say that body is not sliding, it is gliding, right? The friction will be very less, okay. And everything before that, okay, for any other velocity before that, you can say that the kinetic friction is just equal to its limiting value, the maximum value. Got it? Yes, no? Okay, so before the critical velocity, kinetic friction is just equal to mu k multiplied by normal reaction. There is no other value, okay. All right, and then there is rolling friction. And see, we know that if one body is rolling over the another body, then friction will be very, very less, okay. So ideally the friction is 0 because this is not at all sliding over another body. What's happening is, so suppose, see this body or this circular wheel, you can say, it is kept over this surface, horizontal surface. When it begins to move like this, now when it is kept, when it is at rest, there is only one point of contact. Ideally there should be only one point of contact between this body and this body. Now when it moves like this, what happens is this part will fall down and this part will be lifted up, okay. This part will be lifted up, this part will fall down, right? So this part, you can see the next part, it will fall down, and because of that this point of contact is lifted up and the another point of contact will be established between the wheel and this floor, right? The point of contact will just change. So this doesn't mean that it is sliding. Okay, so ideally there should be no friction because this is not at all sliding over this body, right? But practically what will happen, there would be some contact between this one and this one, okay, and there will be some sliding also when one body rolls or another body. Practically there would be some sliding, okay, and that's why there is some friction, but it is always less than the static friction and the kinetic friction. And kinetic friction is also called as dynamic friction. So this thing is clear? Yes, no? Right, good. Then let us see some simple problems based upon the friction. A body of mass m is kept on rough horizontal surface. Coefficient of friction is mu. Horizontal force is applied on the body, but it does not move. The resultant normal reaction and frictional force acting on the object given F, where F is. Tell me. Okay, so what is F? A body of mass m is kept on rough surface. Coefficient of friction mu. Right, this body is kept on this surface, and horizontal force is applied on the body, but it does not move. Okay, so resultant normal reaction and frictional force acting on the object is given F, where the F is. Tell me. You apply some horizontal force, let's say F. Okay, so I will call it F external. So they are asking about resultant of normal reaction and the frictional force. So that is the total contact force only, and that is F. Okay, so now we know that the frictional force, it will oppose this thing, sorry, total external force is in this direction, suppose, then the frictional force will be in opposite direction, this direction. So this is frictional force. Okay, let's call it Fs, and the normal reaction will be upwards. Normal reaction is upwards, so this is normal reaction, and this thing is what? This is the weight. The normal reaction and weight, they will balance each other, so N is equal to mg. Okay, you can just say that F is equal to, what will be magnitude of F? It is just equal to square root of normal reaction square plus Fs square. Okay, and at max you can say that Fs would be Fs max. Okay, so F maximum value of F is equal to what? Square root of n square plus what is Fs max? It is mu s into normal reaction. Okay, and then what you can do is, what is normal reaction? It's equal to mg. All right, then you can take normal reaction common, right? Normal reaction square common, and you can take it square root. So you have n multiplied by square root of 1 plus mu s square. This is the maximum value, right? 1 plus mu s square. Okay, and n is equal to mg, so that's why it is mg multiplied by 1 plus mu s square. So this is the maximum value when the frictional force becomes maximum. Okay, that means it is less than or equal to this value. F is less than or equal to this value. This thing is clear, everyone? Yes, no? It's option C. Okay, so this was a simple question, right? Let's see another one. Angle of repose is equal to angle of limiting friction. When a body is just at a point of motion, that means it just begins to slide, the force of friction of this stage is called as limiting friction. Okay, so tell me what is correct? Assertion, reason. Angle of repose is equal to angle of limiting friction, right? So this thing is correct, assertion is correct. Okay, and then when a body is just at a point of motion, the force of friction at this stage is called the limiting friction. Yes, no? So this one is correct, this one is correct, but does it explain this thing? Does the reason explain assertion? Yes, no? Actually, it explains assertion if we apply it to an inclined plane. Okay, because the angle of repose comes from there only, right? Is this thing clear? So it is option A. Okay, we applied that thing only to find out the angle of repose. Okay, so it explains. But now I just wish it should be more clearer, that they should have told this, that when it is applied to, when this fact is applied to an inclined plane. Okay, so some provision like that should have been made in the question. All right, but it explains, we know, right? Okay, which one of the following statements is incorrect? Frictional force opposes relative motion. Is this correct, incorrect? Correct, right? Limiting value of static friction is directly proportional to normal reaction. Correct. Rolling friction is smaller than sliding friction. Correct. That means we don't need to check what is the last one. Okay, so this is the answer. This is incorrect. But let's just read it. Coefficient of sliding friction has dimensions of length. Is it true? Not true. Why? Because mu s is equal to what? Fs divided by normal reaction. So this is a force, this is also a force. So that means units will get cancelled out and there will be no dimensions. So mu s, the coefficient of static friction or sliding friction, it is dimensionless, right? Mu s is dimensionless. Okay, very simple. All right, then let's just see one. A marble block of mass 2 kg lying on ice when given velocity of 6 meters per second is stopped by friction in 10 seconds. Okay, a marble block is stopped in 10 seconds, then the coefficient of friction is. So there is a marble ball which is rolling on ice. Okay, so it's rolling on the ice and there is some initial velocity 6 meters per second and it is stopped by friction in 10 seconds. Okay, so what is the coefficient of friction? This is the question. So you know that what is acceleration? Just find out. Not acceleration, deceleration of this one. So deceleration is final minus initial velocity divided by time. Okay, how much is that? So that is equal to final velocity 0, initial is 6, time is 10 seconds. So it's minus 0.6 meters per second square, right? It is decelerating, and it is decelerating because of what? Because of the frictional force. So you can say frictional force Fs max is equal to, I will just say Fs is equal to mass into acceleration. Okay, but we'll just take the magnitude of acceleration because friction would also be negative, right? If it is moving in this direction, friction will be negative only. Okay, so this is equal to mu s multiplied by normal reaction, that's equal to its mass times A, and because it is moving on the horizontal floor, because inclination etc. is not given, so you have n equals to mg, right? N must be equal to mg, right? So n is equal to mg, put that. So then this m gets cancelled out. Okay, so now take g on the other side, so you get mu s is equal to A divided by g. So what's that? What is A? A is 0.6. What is g? Let's take 10. Okay, then 0.6 by 10 divided by 10 is 0.06. So that is mu s, right? It's option C. So this one is clear? Yes, no? Okay, good. So now we'll stop at this point, and remaining questions based on friction, next topic we'll see tomorrow.